All right, here we are back here in Unit 6. So we are going to start Unit 6, which has to do with polynomials. So today we're going to do a nice little overview of polynomial functions, and then next couple of classes we can get into the roots and how to do all our synthetic and long division that we need to solve and factor out our polynomials. All right, so let's get started. So what is a polynomial? Okay, so a polynomial is an expression with two or more terms. Okay, so we need two or more terms, and usually these terms are added together. Okay, so what we have is, I shouldn't say usually, all of the time they're added together. So if we had something like 2x squared, so we can go back to our quadratics, right? Plus x plus 4. This would be a polynomial because it has three distinct terms. Okay, now most time this we term as a trinomial. It is technically still a polynomial, but polynomials we usually get when there's four or more terms. So the actual definition is two or more terms, but for our sense it's going to be four or more terms. So when we add this fourth term here, now this becomes a polynomial, and we just do this for four or greater amount of terms, okay? Because when you have three terms, the trinomial. When you just had two terms, this is a binomial. There we go. And then one term would be a monomial. So those three things have actually some specific names, whereas polynomial is just basically any function with four or more terms. However, these are all under the umbrella of a polynomial. It's kind of like when we were in geometry class and you had parallelograms, but inside that umbrella of parallelograms you had a rhombus and then a rectangle and then a square, and there were specific shapes in there, but those are all under the umbrella of a parallelogram, or even the bigger umbrella of a quadrilateral. Okay, so similar idea here. All right, so how do polynomials behave? Well, there's two general functions. So it has to do with our degree is even or odd. So the degree is the highest exponent value. Okay, so something of x to the 6 would be degree 6. Okay, that's 6 so you can read it a little better. So the degree is the highest exponent value. So when our degree is even, okay, so we can kind of think of this back to our quadratic, right? So if our degree is even, such as like an x squared function, our end behavior is actually going to end in the same direction, because the even exponent is going to make a negative number positive. Okay, so as we go in here and x is going towards infinity, so as I'm going towards the right, my y value is going to continually increase. So y is also going to go to infinity. Whereas when x goes to negative infinity, again, I'm going to plug a big negative number in here, but what that's going to get out is a big positive number. So then it's going to be positive. However, when my a value was negative, so if I had negative x squared, what we remember from our quadratic unit, it's now going to reflect my graph over the x-axis. So it's still going to end in the same directions, but it's going to be opposite of what it was when it was positive. So as x gets really big, y will get very negative. As x gets very negative, so will y. Okay, so even functions always have the same end behavior. So the end behavior, whether x is positive or negative, will end in the same spot. Odd degree functions behave a little differently. Okay, so an odd behavior, or an odd function, so let's say x to the third, right? So as x gets really big, so if I put in a really, really big number here for x to the third, my y value is going to get increasingly bigger. Okay, so if I plug 1 million into x to the third, 1 million to the third power is some gigantic y value, so y is going to go to infinity. However, if I do negative 1 million to the third power, there is no cancel out of the negative because there's an extra negative term, so actually that becomes negative in itself. So odd functions end in opposite directions. So if a is positive, it will start negative and grow positively the whole time. The opposite is the case in which I throw a negative in there, because now all these negative terms here get flipped up because of this extra negative. So what was negative, I then multiply by a negative value and it's going to become positive. So this term then, as x goes to negative infinity, y is actually going to get more positive. And then the opposite is true here, as these all were all positive when it's x to the third. If I throw a negative in front, they now become negative. So it goes from, as x goes to infinity, y is going to go to positive infinity. So these are the general rules, and I would highly, highly, highly recommend, really focusing on that and thinking about it, so that's kind of ingrained in your mind, because that's going to be really, really important as we go through all this. Okay. All right. So if we just look at these polynomials, the term we always focus on is the highest degree term. So here I have x to the third, x to the fifth, negative 5x to the sixth, and then negative 4. So negative 5x to the sixth is the term I'm going to focus on, because that is the highest degree. It's degree 6. And then the leading coefficient is just the number in front of it. So in this case, it would be negative 5. So then as x goes to infinity, y is going to go to, well, so I have a negative a value in front of an even exponent. So if my a is negative, they are both going to go to negative infinity, because it's going to flip that graph over. All right, so here they give it to me in factored form, but again, I only care about the x terms. So I'd have this 2x here, and then I distribute it to that x, so then I would get 2x to the third, and then I multiply that by x plus 4, and I would get 2x to the fourth. I'm sorry, this is 2x squared. This would be 2x to the third. I'm sorry, I don't know why I added an extra x term. Because x times x times x is x to the third, and then the 2 carries around for a ride. So the leading coefficient would be 2, and the degree would be 3. So positive odd value, as x gets bigger, so will y. As x gets smaller, so will y. Okay? Here, same idea. I have 2x squared, so this is going to be 4x to the second power. I'm not going to add another exponent. Times x, I get 4x to the third, and then times negative 1/2, that would give me negative 2x to the third power. So now I have odd degree with a negative exponent, and I would get, so as x is going to get bigger, y is actually going to get smaller, and as x gets smaller, y is actually going to get bigger. Okay, and here we have the last one. Here we have 2x squared times x, so that's going to be 2, and this is going to be x to the fourth, because I have 2 x's here, 1x and 1x, it's 4 x's. So x goes to infinity, y goes to infinity, and x goes to negative infinity. Y also goes to positive infinity because of this even degree. All right, so let's look at some actual graphs. Okay, so here I give you a nice picture of our x to the fourth term. It's what's known as a quartic function. Okay, put that up at the top here. This is a quartic function because it is x to the fourth, degree 4. All right, so that is my first thing I needed to figure out. What's the degree? It's the fourth degree. Okay, so end behavior, well, I can do that without even looking at the graph, but the graph does help. Okay, I have a negative a value, so it looks like I'm going down and I'm going down at the end. So don't get bogged down with what's happening in the middle. End behavior is the ends of the function. Okay, and both of those are going to negative infinity, so as x goes to infinity, y is going to negative infinity, and as x is going to negative infinity, y is also going to negative infinity. Okay, turning points is a new thing for us. Okay, so turning points are where it switches from an increasing function to a decreasing function. So right here, this would be a turning point. Okay, as I go, I'm increasing until I hit here, and then I'm decreasing. So in our quadratic unit, that would have been known as a vertex. Okay, what they're actually known in this situation, this would be what's called a local maximum. Okay, because there's going to be several of them, so we just label them as a local maximum or local minimum. So here I'm increasing, oh, I was decreasing here, so here's one more here, and then here's another one here. So there are 3 turning points in this graph. Now the general rule for a turning point is that it's one less than the degree. However, there are going to be situations in which that doesn't actually follow true, okay, because we're going to have double roots or triple roots and it's going to throw it off. Okay, but it is the general rule that the amount of turns, it's going to be one less than the degree. Okay, all right. So my increasing and decreasing, I'm not really going to worry about here because we're going to have to use something like Desmos or our calculator to figure out. And if I exit out of the screen, all my fun little writing is going to go away. So I'm just not going to worry about these at the moment. My x-intercepts, we can see, are, here's -2, 0, -1, 0, 0, 0, and 4, 0. And starting in the next couple of videos, we will go through how to actually find those algebraically. Okay, this first overview, we're just looking at the function and catching them out. And since I have x-intercept at 0, 0, my y-intercept is also 0, 0. All right, the domain. So the domain is always what x can't I plug in here? Okay, and there is nothing that's going, I'm able to plug in that makes this function go to undefined. So actually the domain of all polynomials is going to be negative infinity to infinity. Okay, there is no value that you can't plug into an x or for x. All right, and then the range, well, this one's facing down, so it'd be negative infinity to whatever this little turning point is up here. Let's just say it's about 62. Okay, just because I don't have my graph, we would have to actually plug this equation in to Desmos to figure out what exactly that highest point or highest y value was. But in this case, we're just going to kind of guesstimate where it is. All right, so there's my example of an even function. All right, now let's look at an odd function. So we got an x to the third here, so this is known as a cubic. Okay, because of this nice little third power. So that is the highest term, so that is the degree. Okay, since our a value is positive, as then x goes to infinity, y is going to go to infinity, and as x goes to negative infinity, y goes to negative infinity. All right, don't get caught up in the fact that like over here on the side it doesn't look like x goes all the way. This does still go because remember our domain is always negative infinity to infinity. Okay, so this is still going to be going down like this, and this is still going to be going up like this, on and on forever. Okay, all right, so our turning points, well, here's one, and there are 2. Notice still following that general pattern that it's one less than the degree. Okay, increasing, decreasing, we're not going to worry about. at this point in time. X-intercepts, so there's 1 here, 3, I'm sorry, 1 here at 1, 1 here at 2, and 1 here at 3. So 1, 0, 2, 0, 3, 0. Awesome. And then our y-intercept, well, if we just plugged 0 in for all of this, we would get our y-intercept is right here. So just like in a quadratic in standard form, our y-intercept's our last term right there. So that would be 0, -6. Okay, we can also look right here at the graph, and there's my y-intercept right down there at -6. Okay. All right, and then the range for odd functions is always very easy because these things are not stopping ever. It's coming up. It's going to do some fun stuff around the x-axis, and then it's going to shoot right back up towards infinity. So the range here is from negative infinity to positive infinity. Okay, so it's going to shoot right up there. All right, so hopefully this was a nice little kind of intro to our polynomial functions and what's going on. Definitely go through, check all the homework and stuff. All the answers are on our Google Classroom, so you can look at those as you move through here. And then next class we'll talk about the roots and start dividing some stuff. All right, have a good one.